夢の街のび太ランド
This is Doraemon. It's one of the most memorable anime from my childhood. I loved it because at the time I was interested in almost anything futuristic, but also for its quirky and unique gadgets. I'd get super excited every time he pulled out a gadget from his 4-dimensional pocket, and I'd play a guessing game to try and figure out its functions. It's also pretty interesting to see how our protagonist Nobita would use these gadgets to cause a lot of mischief.
はい出来上がりミニチュアのうちかうわあうちの中まで
Among the vast array of gadgets, I had a few that I considered to be quite novel. Ideas that were so new to me as a kid. One such idea is the Koekatamarin. This is a potion-like gadget that, when consumed, gives the consumer the ability to shout words into existence. Looking at how Nobita uses it, you quickly realize how handy it could be in real life. So I thought to myself, I had just completed an audio classification project, and since this also treads on a similar path, why not create my very own gadget that quite literally adds weight to words. This is Unity. Yellow box. Green screen. Attack. White House. Look at that trash. Hey Google, how far is Pluto? The first step in spawning whatever someone says is to convert their speech to text, and then add a dimensional quality to that text. I was planning to create my own deep learning model to recognize speech, but that comes with a lot of hassle. Having experience with building a custom deep learning model to recognize just 2 whistle sounds, collecting training data is not a joke, especially with something like speech, which has a lot of variables we need to take into account. The other problem is that even if I could manage to scrap together a decent dataset, the model will still have a bias towards my speaking style and accent. So I decided to go with a pre-trained model with a big enough dataset, specifically Google. The reason I chose Google over the other offerings, including open source ones, was simply because I saw firsthand how fast and accurate Google was. Also, one of the main requirements of this project is to run the speech-to-text process in real time. So if you say something into the mic, at that instant, something should happen in the game. I knew very early on Google was capable of real-time transcription, and they even claim it could do faster than real-time. Hey guys, this is the Python program that I put together for the Google Speech-to-Text API. Now I'm going to say some random words to demonstrate its function. This is a Python program that I quickly put together. Well, when I say I put together, I simply copied a sample code from Google. And as you can see, the Google Speech-to-Text API is doing pretty good. It's fast as is, but if you set the interim results to true in the streaming configurator, you can somewhat see the faster than real-time claim in action. Speech-to-Text API. I'm going to demonstrate its function in real time by saying some random words. Hey guys, Pokemon, Pikachu, Rayquaza, glass box, speaker. With the sheer size of the dataset, Google pretty much knows what you're about to say, and even if it is wrong, it automatically corrects itself. I'm honestly still amazed by how fast computers can do things, and I'm looking forward to the day when we can truly predict the weather. Anyway, now I have a working speech-to-text program. What next? My initial thoughts were to stop here and do what I did in my last project, which is to create a network between Unity and Python and let them run in parallel for data transfer. But since the Google API already had C# support, I thought I could make things less clumsy and easier for the user by implementing everything on the same platform. When I was looking to implement the same program in C#, I quickly ran into a problem. There were no examples or help relating to how to use the Google API in C#. Now, don't get me wrong, Google had solid documentation and even an example project, but it was for offline transcription. So with just that and the Python code in hand, I began the tedious process of translation. Most of it was just me experimenting with different code, and some of it looking for answers on forums. And so after a long week of work, I finally had a console app that does exactly the same thing as my Python app I put together for the Google Speech-to-Text API. This application is a translation from the Python sample code that I got from Google's website. And as you can see, it works pretty well. Now it is time to add the C# code to Unity. But of course, like with anything in Unity, things wouldn't be as straightforward as one might expect. The initial errors were related to missing packages, which I resolved by installing them manually. Next, I got errors related to some duplicate Newtonsoft file, which once deleted kept respawning in my Unity folder. Then there was the error related to every Google API dependency. It seems there's a conflict between the default Unity Newtonsoft version and what Google requires. But as I mentioned earlier, there's no point in deleting the default version. After looking into this, I came across this particular comment in the Unity forum. Once I saw this, I knew working on this any longer would just cost me my time, and also I was pretty lazy to debug all these errors. So I decided to take an alternative approach. This was the state of my project. As you can see, I already had a way of getting the input data through my console application. The only thing left to do now is to take the input data to Unity to make my speech gadget. But how? As I mentioned earlier, I've already worked in a similar setting. The solution is to create a network between the two apps so they can communicate with one another. So I quickly set up my server side to look for two messages once a client connected to it. Start recording, which instructs the server to prepare the speech client and the mic input for recording. When the recording begins, the transcript data is sent back to the client through the same network. Stop recording, which tells the server to shut down the mic and the speech client. I shut down the speech client as well because it was easier for me to predict when it would crash and give errors. The only error that I encountered during testing was one that indicated an overflowing buffer. This is usually caused by a slow internet connection when the buffer is already full, waiting for a response from the server. So here's how things stand. When in game mode, I first connect to the server, then press the left mouse button to start recording. Hello world, this is Unity. I'm currently inside the Unity game engine. And as you can see, we have a real-time speech-to-text transcription going on. Initially, I set the recording duration to a set amount, so after the duration has passed, Unity sends the stop message to the server. I did this because Google can only tolerate a certain amount of silence period before it actually shuts down. Now it's time to work on the spawning system. First, I had to get my hands on some alphabets to spawn, so I chose this model from Sketchfab. It's pretty stylized, which I think fits the vibe of this gadget. After exporting them as individual characters, I gave them all a rigid body, a cube collider, and a bouncy physics material so they can work with physics. As for the script itself, it was pretty simple. First, for testing purposes, I set the trigger as the left mouse button. So when it is clicked, I call this function. It takes a string as an argument and loops through each character to find its match from the alphabet list. If a match is found, then it instantiates the character at a set distance in front of the player. For consecutive letters, I just added an offset to the distance, so they spawned something like this. I also added an explosive force to their rigid body. This already looks pretty cool, but it wouldn't be Koekatamarin if it doesn't turn our speech into 3D words. So let's implement that as well. This time, instead of using the left mouse button as input, I called the word builder function when I received a transcript. I did this by referencing the spawn script in the speech receiver and called a new function called the setup speech here. This function just prepares the transcript so that it's ready to spawn. However, it seems that it can only be called on the main thread, and since we are receiving the messages on a separate thread, Unity doesn't like it. So I used this script that I found online to call the same function on the main thread, and here's how it looks. Letters, words, ice cream, game mode, green screen, staircase, smooth operation. I was so excited and equally relieved to see my idea come to life. And surprisingly, it's super fun just to blabber random words and see them spawn right in front of you. I was all the more impressed by the almost instantaneous response. But do keep in mind, for now everything the Google API sends back will be spawned. This includes the interim results as well. If I had to turn this off, I'd only receive the final transcript, which comes at the cost of speed. Usually I don't bother making UIs because I don't release my projects. But this time I wanted to package this as something you guys can experience as well. So it's important that you know when to speak and not to speak. So I added a simple speech timer, which lets you know when the speech client is ready and how much time you have left to speak. It was also at this stage that I made a simple modification to the system. Instead of letting the user speak once for a set amount of time, I made it so that the user has 5 to 8 seconds of speaking time. Once the timer runs out, the speech client shuts down and the user has to initiate the recording once more. Nothing special, just like the attack mechanic in any other game. This way the process can cycle infinitely without worrying about silence periods. I was pretty satisfied with how things were at this moment, but I still felt like something was missing. What's the point in simply shouting words at the sky, ground and walls? So I thought I'd add some simple enemies as well. For the enemy visual, I used this floating robot model from Sketchfab. I chose this because I didn't want to animate anything, and since it's floating, I can just rotate it through code and it will look just fine. As for the behavior, I wanted the enemies to patrol a given area, and when the player gets in range, chase them. The pathfinding can be easily done using Unity's nav mesh agents, so I won't cover it here. The behavior goes as follows. We check if the player is within a given range using the physics.checkSphere. If they are, then we call the chase function. If not, then the patrol function. This is the patrol function. The important part to note here is the call to the search walk point function. This essentially just returns a random vector 3 point, which we then set as the destination for the agent to follow. If the destination is reached and there's no player inside, then we repeat the process. As for the chase function, it's even more simple. We just set the agent's follow destination to the player's current position. Now for them to take damage. First, I thought of making it so that they take damage for just about any letter. So no matter what the player says, the enemy will take damage. I did this by using the onCollision enter function. I simply checked if the colliding object is a letter, and if it is, reduce some health points. Once the health is less than 0, I just destroy the game object. It's important to note that during this stage, I reworked the word shooting mechanism. Instead of spawning them with spacing to emulate words, I simply spawned each of them at the same position in front of the player. This way it looks like the player is shooting each character as he's uttering it. Also, there's no more of this. Even though this was fun to play around with, I still feel like there was something missing. So I decided to take it a step further and implement a tougher enemy called the tough enemy. The tough enemy has the same behavior as the normal enemy, but I made it so that it only takes damage from certain words. But before we get to that, let me quickly add some UI to indicate the health bar. This way we know what we're dealing with. This is using the same technique as before. I simply used the default Unity slider and tweaked its value during runtime. Okay, back to the tough guy. First I had to generate some random words that could affect him. I did this with the help of ChatGPT. I told it to give me a list of random words and pasted those into a separate class. This way I can access them wherever I need. Then I made one modification to the onCollisionEnter function. I just checked if the transcript from Google matched the current random word. If it did, then take damage. I also made it so that after each word is completed, a new random word is selected. I also added a TextMesh Pro component to display the current word above the enemy, so the user knows what to say. Die. Go on. Meadow. Art. Heart. ART. Cascade. Whimsical. Climb. Universe. Dive. Crystal. Candy. Euphoria. At this point I pretty much had a solid game. Well, more like a proof of concept for my gadget. But remember, I want to package this as something you guys can experience as well. But there's a hindrance in the way. The console app. Up until now I had to manually open and run both the console and Unity. This was obviously frustrating and very time consuming. Lucky for me, it turns out there's a way to open the console applications through code. So I made a separate script that handles just that. This code is pretty self-explanatory, so I leave it at that. And once the user closes the game, we can terminate the console within the onApplicationQuit function. So that's pretty much it. I've learned quite a lot working on this project, and it's about time that I moved on to something other than audio domain stuff. If you made it till the end, here's a special candy for ya. With that said, thanks for watching, and I'll see you in the next adventure.